think we're ready to go. So this is Codyssi Challenge Set 2, Challenging the Whirlpool, Problem 12. The rest and relaxation was definitely a good call. A whirlpool of epic proportions begins to swirl around your vessel. Sharp, jagged teeth pierce through the water surface. A dozen aged tentacles swirl through the air. Charybdis, the whirlpool monster, has woken up. Your team springs into action. They look for patterns in Charybdis' actions and measure the nearby water waves' amplitudes. Anything to get more information. The data is rapidly verified and sent to your laptop. You don't have much time, so you just have to work with what you've got. Your file starts with the 30 by 30 grid of integers representing the initial amplitudes of the water waves in the region before Charybdis woke up. The top row is considered to be row 1, leftmost column is considered to be column 1. This is then followed by 400 instructions, representing Charybdis' actions. Finally, this is followed by 300 flow control actions. All right. Each instruction either shifts the position of values in the grid or changes the values in the grid. Shift instructions are formatted as shift row col number by shift amount. These instructions represent a cyclic shift of a row or a column. Rows are shifted to the right, while columns are shifted downwards. The shift amount determines how many spaces, probably positions, how many positions each value is shifted by. Right. So shift row 1 by 3, and if row 1 is this, we shift it to the right. So this goes 1, 2 to 3, wraps around. Yep, 8, 2, 3, 1, 5. Okay, that makes sense. Change instructions are formatted as either add sub multiply amount, row col number, or add sub multiply all. The keyword add represents an addition, sub is subtraction, and multiply is multiply. All right, no division, I guess. If it's all, it affects all the values in the grid, whereas the instruction row col only affects the values in one row or column. Okay. The reason I said is I'm trying to think about how to generate an enum with this information. If row 3 was this, and it says add 7 to row 3, then we add 7 to row 3. To model the whirlpool better, each value in the grid must be between 0 and that inclusive. If a value ever leaves that range, then that number is added or subtracted. Okay, so just mod by this. All right, simple enough. For example, if row is this, then change to blah, 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 blah. Okay, for your warm-up, you have to perform all the instructions in file order, ignoring the flow control actions. Then you must find the largest sum of the row or column. Okay. And then what's the largest sum of the row or column in the grid? Very good. Let's do this. Copy. Let's go into input problem 16 text. Paste out in. Our final thing is act. We haven't learned what this third section is going to be for, but it's easy to imagine that's going to be part 2 and 3. And 1069 is at the top. All right, let's write that. Flip over here, hit run. What do we get? Nothing. Perfect. All right, so let's do what we did before. Sections is going to be in new line, new line. All right, so we should have 3 sections then. And we do. It says 3 right there. All right, so our first section is going to be the grid. That should be fairly easy to do. Let nums. What is this? Does this have a specific name? They're just values. Okay. I mean, it was something about amplitudes. I don't want to try about amplitudes all the time. Let's just call it values. Is equal to sections of 0. Dot split on the new line. And that'll give us each line. So we can say then map line into line split on space. We're going to map that into a num parse I64, unwrap, collect into a vec. and then that gets collected into its own vec. So we have a two-dimensional array, and we can actually just print that out, and we should be able to see all the numbers. It's going to be very big. But it starts with 1069, and it goes all the way to 69,394 right there. Okay, so that worked. The next thing we want to do is the instructions. So we have add, multiply, add, subtract, multiply, or shift are the main operations. So let's do that. Yeah, let's just call it oper, which is going to be shift, add, multiply, or let's put it in order, sub or multiply. So how do we want to do this? Because we want to specify a row or column or an all. So maybe we can do is enum, what do we want to call it? Range is going to be a row, a column, or all. Maybe we can do it that way. And then we're going to say shift of a range and an amount. We're doing I64s. Add range amount, sub range amount, and multiply range amount. I guess one of the things is shift. There's no shift all. And one of the important aspects of Rust is to make illegal states unrepresentable. So having a shift all, since that's not a valid thing, we shouldn't do this. I'm debating whether or not I should create a second range that includes all, like this. Oops. And then shift only gets range, and then add, subtract, and multiply get range all. Or if I should create a shift row and a shift col separate to add, sub, and multiply. I don't know. I guess it depends on when we actually go for implementing the work. Let's do a shift row and shift col and see how bad that is, and then we can always change it later. I don't know how I got an extra capital P in there. All right, we don't need the values anymore. So why did I do this? Because I need to parse all the instructions. Let instructions is equals sections of 1 split on a new line. And we're going to map line.parse oper unwrap, and collect that into a vec. So then instructions should be a vec of operations, and it is. Okay, and now we just need to write it. We can't do this yet, but we'll do it right now. Impl from stir for oper. We pull in the from stir trait. We implement the missing members. We're going to assume that everything works fine, and now we just need to parse these things. So let's keep this over here so we can keep an eye on what we're parsing. First thing I'll do is split the line into words. Let's call it line. I keep using S because that's what they have, but line. There we go. Split on space, collect vec. All right, so now we have all of the words, and we can match on words of zero. And this is going to be shift, add, sub. Let's do things, keep things in order, and multiply. And then otherwise it's panic. Invalid instruction line. All right. And what we need to do is return an OK of our type. So shift is going to be shift row call. So we can look at the word of one, right? Match words of one. If it's row, then we're going to generate a self shift row. And we're going to do the row number in here. So that's words of 2. And then the amount is going to be words of 4. Right? Yes. And then we do call, which is the same exact code. And then we're going to just have to stick all of these in here, I think. Right? So this will allow us to parse the shift row call. I probably should write tests for these, but I'm not going to. What I'm going to do is just dump them out at the end and see if they work. Okay, so add is the next thing. And it's going to be add amount row call number or add amount all. Now these are all going to be the same. What we can do is match on 1, right? Sorry, this is 0, 1, 2. So if we match on words of 2, it's either going to be row, call, or all. Okay. Match words. And what I'm going to do is I'll write it for add, and then I should be able to just copy paste it to sub and multiply. So this is going to be row, call, or all. And then that'll give us our direction, right? So this will be self add. Sorry, not the direction, the range. Range row, words of, oops. Okay, words of the next one, 0, 1, 2, 3, right? So 3. By the amount in words of 1. Like that. And then the next one is going to be call, and the next one's going to be all. Okay, so we'll just do that. This becomes call, and this just becomes all. Like that. Right, and now we can do the same thing. Let's put this on a separate line. And we can do the same thing for subtract and multiply. We have an error here. Expected operator found on. Oh, I need to add this guy in here. Okay, hang on. Oh, I didn't want to do that. I wanted to keep it all on single line to make the copy and the editing easier. So there's multiply and there's subtract. So this will be sub, and this will be multiply. We have to get rid of these guys now. There we go. Still says mismatch. Okay, no, it's fine. We're not using any of the stuff. We got 9 warnings. We did not get a panic, which means we were parsing it correctly. Let's print out all the instructions and see if we got them right. Println instructions. Yeah, I know, we're not using anything yet. Okay, it starts with add call 2141. Oh, right. We start at 1, 1, right? So we need to subtract 1 from everything here. Oh, it's not going to work, right? It's going to complain that I have to tell it it's a use. Let's do this. Fn get row call. And this will just be stir. Let's say val. And it's going to return a usize. And we'll say val parse usize unwrap -1. And then we'll just put that in here. Get row call of words of 2. Oops. And we'll do that. We'll have to do that everywhere now. All right. And that'll subtract 1. We should be able to see that in the in the shift I was going to say, but get row call words of 3. That's an easier way to do it. Do it there. That's an all. That's a row call of words of 3. They all came out to be 3s. That's good. Okay, I hit Control D. I don't know why I jumped to the end, but it did. Okay, so now we have add column 20. Let's flip over here. So I add 41 to column 21, 41 to column 20, right? That's good. Okay, and we'll go down to the end of that. And it's this should end up being shift row 10 by 5, right? There it is, shift row 10 by 5. Okay, so we have all the instructions now. Now let's use them. And what I'll just do is I'll modify values directly for part 1, and then we can figure out what part 2 is. We might have to clone things and stuff like that. Oops. There we go. So we just say for inst in instructions, and we can do fill match arms. Oops. Oh no, we have to do a match before we do that. Match inst. Right? Now we can do fill match arms. There we go. So shift row R by amount, AMT. Shift column by AMT. We get a range here, and this is all AMT. There we go. Yeah. It failed because we hit a to do. Yeah, not yet implemented. So the first thing is line 32. Let's implement that one. Here we go. So the first thing is an add. We're given a range to add to. So match range. Row R, column C, or all. The all case is easy. For row in values, for item in row, I don't know what I have to do here to make this. I don't want to consume it, but we'll see. So item plus equals amount. Right, because amount is a reference, yes. So that should, yeah, that compiles fine. Okay, so the first thing we're doing is line 34 now, which is add to a column. Is that true? Yes, add to column 20. Okay. So I think once I do add, then I should be able to copy paste for sub and multiply. That should be easy enough to do. All right, so we're going to add amount to column C for row in mute values, row of column C plus equals amount. This one's a little easier, right? All we have to say is values of row, iter, mute. Oh, let's just use a for loop. For item in values are like that. Item plus equals amount. Yeah, I think that's all we need to do. And the next thing we panic on is line 52, which is the multiply. So we should be able to do multiply the same exact way. Except instead of adding, we multiply. This feels like one of the ones that we're going to need to test thoroughly. Okay, line 31. This is shift, so this must be the third. Yeah, shift col 25 by 6. Okay, so shifting columns is going to be tough. How do we want to shift a column? And it's shifted downwards, right? Oh, I forgot about this. Ooh, I'm glad I looked at this again. We do want to make sure that we mod everything by the right amount. So I should say item equals item plus AMT mod that, oops, not 52. This value. Oh, that's the other thing. If we subtract below that, does the mod, do we have to use the, what's it, Euclid mod or Euler mod or something like that? We have to use a different mod. Oops. Mod this, oops. And then this is the same thing here. Oh, I forgot the star. It goes here. All right, and now we're going to have to replace these guys here. Here. Oh, I didn't do sub yet. Okay. And instead of plus, it's times. Right, I forgot about that. And then we'll do sub in a second. But let's do rotate shift columns. Shift columns is going to be not easy. I'm thinking about the easiest way to do it would be to shift everything down by 1. Write something that'll do that, and then just loop over that. There's not a lot of instructions, and they don't do very much. So even though that's a slow way to do it, it's probably the easiest way to get it right the first time. So we're going to go amount number of times of star amount, and we're going to shift down by 1. Now, how do we shift down by 1? We'll copy the last item in the column. Let last is equal to values len minus 1 of the column that we care about. I'm going to use values len a few places. Let's grab it here. Len equals values len. So len minus 1. And then what we'll do is we'll loop over from the bottom to the top. Let's make this mutable. Len minus equals 1. And we'll say values of, we say while len is greater than 0, values of len is equal to values of len minus 1, of C. And then len minus equals 1. And then at the top, we'll put, and we'll test this with this test input because they have a shift call 2 by 1. So we should be able to see that. And then values of 0 of the column gets the one that used to be last. So that should shift everything down. Syntax error expected in KW. Oh, I forgot the in. In keyword, that's what that meant. In KW. All right. So now we panicked on line 34. Oh, because we have to grab the length each time. Yep. And line 62 now, which is subtraction. Okay, so we say match range, and we'll grab all these guys, those in there, and instead of multiply, we're going to do subtract. And then line 30 is not implemented. Shifting a row is easy because it's built into Rust. We can just say values of row shift right by amount. I might have to tell it. Uh-oh. I thought that was a shift. Is there no shift? Shift? There's no? Is there rotate? Oh, there we go. Rotate right by amount. Oh, I forgot to look at the type. It's taking U size. So let's make these U sizes instead of I64s. All right. And now we're able to execute all the instructions. And we need to find the largest row or column, right? So let's just do it. See if we got it right. If we got it right, then yay. If not, then we'll run some tests. Row max 0 for row in values. Row max is equal to row max of row iter sum. I think. I'll just print it out just for now. Yeah, so we got an answer. To sum up the columns, we're going to say for col in 0 dot values 0 len. For row in values, I guess. What's an easier way to do this? Values iter map row of col sum I64, right? And we'll do the col max is col max this. And then this becomes row max col max. And we got a number. Is it right? Oh, wow. Okay. Yeah, that only took a half hour. Very good. I'm in shock. I was worried that the subtraction business with the mods wouldn't work correctly, but I guess we never go negative. I don't know. Let's commit this change. Git add source, git commit -m problem 16. And I've already forgotten the name. Challenging the Whirlpool part 1. There we go. 2 files changed, 177 insertions. Let's continue to part 2. Great. Now that you've got a feel for Charybdis's move, you can begin to consider the flow control actions. Charybdis starts with the sequence of instructions shown in the file, in file order. The flow control actions determine the order of moves she makes. There are 3 flow control actions: take, cycle, and act. It's guaranteed that there is a take action immediately before every cycle or act action. Take means taking the first instruction from the sequence out of sequence. Cycle means putting the taken instruction at the end of the sequence. Act means to perform the taken instruction and discard the instruction. First, perform all of the flow control actions in sequence once. Then, find the largest sum of a row or column in the resulting grid. Okay. So take means take the first one, take it out of the sequence, remove it from the sequence. Cycle means putting it at the end of the sequence. Act means do it, and then throw it away. Okay, so we want to refactor all of this then. Let's create a struct to hold all the values, and then that way we can implement a function which executes an instruction on the grid. So it'd be basically pulling all of this out. And the only reason to make it a struct as opposed to making a separate function is just because that keeps things together. Struct grid, I guess I'll call it. And it'll contain the values, which is going to be a vec of I64. Right? And then I can say impl grid fn execute mutable reference to self and an instruction, which is going to be oper. If I make it a reference to opera, I'm going to have to re-reference everything. So let's make this copy clone so that I don't have to worry about that. And then it's not going to return anything, but then I also can do this and make this a function in here. Fn row call max on self, and it returns an I64. And row max call max. Like that. All right, and then this becomes, oh no, up here, instead of saying mute values sections, we can say this. We can say let mute grid equals grid of values, semicolon. Right, and now I'm going to pull all of this, stuff out. Oops, I missed one. There we go. I'm going to pull all of that in here. And now I have to change values to be self.values, right? There's a whole bunch of these guys. That's all of them? That's all of them. Okay. And now for part one, let's make this clonable, because it should be, right? Oh, self values here as well. Does that build? It does not. Oh, because I did it. I should make this a reference then. Yep. Okay. Very good. So now for instant instructions, we can do for part one, let's clone the grid. Let's do this. You know, I forgot what the answer was for part one. Dang it. Here it is. Let's save it here so I can reference it to make sure I got it right. And then we're going to say we have the grid and the instructions. Let part one is equal to grid clone. We'll just make a copy of it. We'll execute all the instructions on the grid for inst in instructions. Part one dot execute inst. Is it already a reference? It is. And then we just call part one dot row call max. Is that what I called it? I forget now. There's a method I called it roll call max. Let's fix that. All right. And did we get the same number with all that refactoring? Okay, so we did the refactor. Let's commit the refactor. Git commit -am refactor part one. All right, and then part two becomes let mute part 2 equals grid clone. And now what we're going to do is we're going to walk over, what are we calling these? Oh, I'm on the wrong part here. It's called a flow control action. So let's call them actions. Let actions is equal to sections of 2 dot split on a new line. And because it's the last section, I have to say filter line is empty. Because there's always an extra new line at the end. And then we'll say map line dot parse action unwrap collect into a vec. Right? And now we just have to create an action. Let's put that at the bottom here. Enum action is going to be take, cycle, or act. And we're going to impl from stir for action. And it's just batch s. Take is going to be self take. Oh, yeah, take. I got to wrap it in an OK. That's why I paused for a second. Cycle is going to be self cycle. And then act is going to be self act. And then underscore panic invalid action s. And wrap it in an OK. Right? There we go. And now we should have all our actions. Let's print those out to make sure we have them. Make sure we have them all. It starts with take, cycle, take. Take, cycle, take, cycle, take, cycle. Okay, and it ends in act, take, act. Take, act, take, act. Yes. Okay. So we have them all. So now what we're going to do is just operate on the instructions that we need. So we let p2 inst is equal to instructions clone because we need to modify it and we need to make it mutable. So for action in actions, match action, and that'll tell us what to do. Let mute cur inst is none. If we're going to take, we're taking from the first, actually what we should do then is make it a vec-deck, right? Instructions iter. Can I do that? Oops. Vec-deck, because that, I mean, we could do it with a vector. It'll work fine. But since we're doing stuff at the front and the back, and that's what it's for, so we can't do this from a slice. Can we, is there like a from iter? Can I just do it from that? I can. Okay, so I didn't even have to do that. Did that consume instructions though? Can I make it from a reference? No. Because I'm going to need a copy of it for part 3. So, but I'm not going to worry about it. All right, so take is going to be, we're going to pull off the very first one. So cur inst is sum p2 inst pop front. I'm going to put it like this because each match arm has to match. Let's get rid of the actions here. And then cycle just means take the current instruction and stick it at the end. So this is going to be p2 inst push back cur inst unwrap. Which it doesn't like. Cur inst is already, oh, because this already is a sum. That's why. Okay. And then act is going to be let inst is equal to, no, let sum inst is equal to cur inst, else panic action on non-instruction, which they promised would not happen. And then we're going to perform the instruction. Yeah, maybe I can do it as references. Okay, we can perform the instruction part 2 dot execute inst, and then throw it away, right? We don't push it back on the back. And discard the instruction, yeah. And then we'll print out part 2, which is going to be the same as printing part 1, except with the new grid. All right, let's see what happens. We get a different, we get the same number. I was all excited about it being different. And I said it before I said it. I'll put it in, but I don't think that's going to be right. Did I do it wrong here? Oh, that's why. Okay, thank goodness. It should be part 2. Now we get a different number. Very good. Hey, it's a correct answer. Okay. Let's check in with Clippy. Clippy's okay. Git commit -am problem 16 part 2. All right, let's see what part 3 is. The captain has sailed through these waters before. You can barely hear his shouting, but it seems like he's got some information. Charybdis can't keep this up forever, as she's got limited stamina. I suspect she'll tire out soon. From what the captain has said, it seems like the Whirlpool will exhaust itself after performing all of its moves. I got to work on that grammar. It's a pet peeve of mine. Quickly adopting your model, you'll loop through the flow control actions until all of the instructions have been performed and discarded. Then you'll find the largest sum. Okay. Yeah, this is why, and I'm thinking I won't be able to do this again, right? If I say part 3, it's going to say, oh, you've used it once. Yeah, it's moved here. So we should do an instructions clone here. And then we'll get part 3's grid here, starting from the beginning. And now it's not for action and actions. Well, it's not just for action and actions. Do I want to move this into its own, I don't. Okay. Because now we just say while not p3 inst is empty. This probably should be outside the loop. I don't know, actually. Let's read this thing here. After all 6 fold control actions are performed the first time, the grid and sequence of commands is this. So then we do it to say, oh, so the first instruction is always going to be take. So yeah, it doesn't matter where cur inst is, because it'll get replaced immediately here. Okay, so we can keep it outside. And I did not do the right thing here. This should be P3. Yeah, this is why I wanted to, okay. Part 3 execute. All right, run. And we panicked action on non-instruction. There you go. So did I miss a 3 in here? Okay, let's print them out because it's going to be big, but that's okay. Println start of cycle. Println action. And what I'm going to do is I'm going to quit out here so we can pipe it into less. Cargo run less. It does say take and then act. Oh, if we've taken the... Yeah, because I'm just checking here. Ah, So I want to do loop here. And then at the beginning, if cur inst is none, and p3 inst is empty, break out. Otherwise, we'll keep going. Right? If there is no current instruction and we can't get a new instruction, then we're done. So let's try that. Oops. Yeah, so we have an answer. And it's the correct answer. After your analysis, you quickly present your findings to the captain as Charybdis' waves and tentacles rock the ship. That's as much as you can do. Your survival depends on the captain and his crew of oarsmen now. Okay, very good. Let's check in with Clippy, as one does.